Hello, everyone. So I will start today's lesson where we stopped. Last time we had one problem left over from 7.1. So here the left-hand side has more terms. So it's much easier to simplify this than to work on the right-hand side. So I'm going to start with the left-hand side. And since I want negative cosecant theta, the left side, I should simplify to 1 over sine theta, then I can get negative cosecant theta. Having said that, so let's replace cotangent theta with sine and cosine. So it would be cosine of negative theta over sine of negative theta multiplied by cosine of negative theta is the same as cosine of theta. So I'm just going to write it the same. So this also will simplify the same way, but this will not. Okay. And so I can write this now as negative sine theta because this is an odd function. So when your angle is negative, the answer is going to be negative. Next, this just becomes cosine theta, and I'm going to simplify this and rewrite it as negative sine theta multiplied by cosine theta minus sine theta. Now, cosine theta multiplied by cosine theta will give me cosine squared theta. And then I will make a common denominator. That is, this has a denominator of 1. I will multiply the numerator and denominator by negative 1 sine theta. Okay, this one. So this becomes, I multiply the numerator also by a negative sine theta. So negative and a negative makes this positive sine squared theta over negative sine theta. Cosine squared plus sine squared theta, one of the Pythagorean identities, if you can remember, is sine squared theta plus cosine squared theta equals 1. It's not there in my notes, but if you look at it, this is one of the Pythagorean identities, and this is equal to 1, so 1 over negative sine theta, which is the same as negative cosecant theta. So the left-hand side equals to the right-hand side, and we are done. Okay. So I had announced on the review day, there are a couple of problems on the last page from this section that is due on the Tuesday after we come back. And that is problems from page 34, problem number 11, and from page 36, problem 15. Both of these are due on the Tuesday after we come back from break. That's December 3rd. Okay. Now I'll start the new section, and that is 7.4, which is solving trig equations. Now, the basic trig equations that we are going to look at is sine theta is equal to a number, cosine theta, or it could be the reciprocal also. Cosecant theta equals to a number, secant theta equals to a number, or tangent or its reciprocal, cotangent theta equals to a number. Okay, now this A is any real number. Since all the trig functions that we looked at so far are periodic, that is, sine, cosine, and their reciprocal repeats itself every 2 pi. That is, we get the same values again, every 2 pi cycle in the case of sine, cosine, and its reciprocal. But in the case of tangent and cotangent, the period is pi. This is part of your test. That is, the period of cotangent and tangent is pi. There is asymptote in the case of both tangent and cotangent. And so the asymptote again repeats every pi period. Okay. So this, since it is a periodic, you should expect trig equations to have no solution, that is, the function is undefined, or it has infinitely many solutions. So in the case of sine, sine will have, is defined if the value of a is between 1 and -1. If it is, if the a is any value above 1 or below -1, sine is undefined. On the other side, cosecant is not defined between 1 and -1. So if cosecant is equal to any number between 1 and -1, it is not defined. So there are certain values where the function is not defined. And where does the infinitely many solutions come? They come from the period. So every time the first period, we will find the solution, and then we will find, based on the period, if you go to the next period, we'll find another set of solutions. So we will look at how to figure out those infinitely many solutions. So here are the steps that we will use. I will talk about in a minute. To find the restricted solution, that is, if we have to use the calculator, when we did the inverse, we said that such that we can find the angle, the domain was restricted. And so in such a way that we could find angles where the function has the positive value and the negative value. Now, so whenever we are using the calculator to figure out the angles, there is like limitations to what angles we can find. We can find angles only in the restricted, and then we will have to manually find all the other angles we want in a given period. Okay. So to find the restricted solution by isolating the trig function on one side and then undoing it with an inverse trig function. The answer is restricted because the ranges of the inverse function. So the ranges in the sine is this, in the cosine it is 0 to pi, and tangent it is this. Based on the solution to the first part that we find, to find all the angles between 0 and 2 pi, we will use the reference angle to find all of it, okay? Now, if the value of sine, cosine, and tangent are such that we are able to find the exact angle, then we will use the unit circle. So on your test, there will be one part again, just like test 5, which will be a non-calculator. You get to use the unit circle. So in that case, the function value will be such that the angle that you get will be some multiple of 30, 45, 60 degrees. Okay. So to find all the angles, we can either use the unit circle or use the reference angle and the sign of the answer in part 1. Okay. Now, talked about how it is periodic, then the same value repeats for some other angles. How do we find that? Since sine and cosine repeats every 2 pi and tangent repeats every pi radians, the other solutions will be just multiples. Let us assume k be an integer. Now, on web assign, I'll assign homework for this section. Sometimes they will say n is an integer. Sometimes they will say k. So please watch for the watch or read carefully what are the instructions. So let's say we found an angle where sine or cosine is a particular. Let's say I found sine theta is equal to 1/2. Then we know that theta is going to be pi 6, right? And then this is the first angle where sine is going to be 1/2. The other is in the second quadrant. So the second angle where between 0 to 2 pi, where sine is going to be positive 1/2 in the second quadrant, will be 5 pi 6. Now, to find all the other values, that is what we will do. This is the A part. The B part would be pi 6 plus 2 pi k. That is, this is where it is 1/2. That is pi 6. Then if I add 2 pi k, then it'll give me the next angle. And I rotate again, it'll give me the other angle. So we just use this notation to represent all the other angles. Of course, whenever you use a variable, we should identify what it represents. So k is an integer. Again, to find all these, the second angles, we will write the same way, 5 pi 6 plus 2 pi k. So it'll be over here. Again, if I rotate again, I'll come to the other angles, the second angle where sine is equal to 1/2. Okay. For some trig equations, you will need to use factoring. We will sometimes need to use quadratic formula, sometimes the square root property, or substitution in order to break down the basic trig functions. That is, sometimes like it was easier if you're given cosecant to just use substitution by finding what would sine be and then use that angle to find the values where cosecant equals to a certain value. Okay. So as we do the problems, it will make more sense. Okay. So solve the equation, find all solutions between 0 to 2 pi. So we are not relying on inverse functions. We are going to find all the angles where sine and cosine and its reciprocal, as well as tangent and cotangent, is a certain value within 0 to 2 pi. Okay, so the first step is to use the inverse on both sides. Take the inverse on both sides. Okay, so this cancels off and that isolates the theta. Theta is equal to sine inverse of negative square root of 3 over 2. So on this page, all the problems that are included are such that the angles are coming from the unit circle, or they are all multiples of 60, 45, and 30 degrees angle. Okay. Now, even though there is a suggestion that to use this value, I would say that first find the reference angle. Now, a reference angle is always a positive acute angle. So if it is an acute angle, then I will find theta where sine is equal to positive square root of 3 over 2. And so if I'm using the unit circle, I have my unit circle over here. So sine is, on a unit circle, we just look at y. So it is positive over here. So my reference angle is going to be pi third because it is always a positive. I know we are interested in where sine is negative, but by using this, especially when we have to find the value of some trig function which is not from the unit circle. We can use the same technique. So I'm trying to be consistent in that way. So this is my reference angle that is theta is going to be theta reference is going to be, or theta prime, whichever is used, it is going to be pi third. Okay. Now we know that sine is negative in the third quadrant and in the fourth quadrant. I will use this reference angle. So in this case, it will be 4 pi third. This is my reference angle. It'll be 4 pi third and it will be 5 pi third. So the two angles where sine is equal to, one is in the third quadrant, which is 4 pi third. And the other one in the fourth quadrant, it is theta is 5 pi third. Okay, this answers the A part, all the solutions between 0 and 2 pi, where sine is negative square root of 3 over 2. Okay, the B part is all the solutions. So 4 pi third plus 2 pi k and 5 pi third plus 2 pi k. Again, identify what your k is. K is any integer. Okay. Okay. So the same thing we will do here. We will take the inverse of both sides. So cosine inverse, cosine theta, and cosine inverse of square root of 3 over 2. So this cancels off. So theta is cosine inverse of square root of 3 over 2. So again, I'm looking at where x is equal to square root of 3 over 2. So my theta reference, or theta prime, is going to be the same. It is going to be pi over 6. So my first angle where cosine is equal to square root of 3 over 2 is pi over 6. So I found the first angle. I will use this as reference angle. So it will be in the fourth quadrant. It is positive in the first quadrant and in the fourth quadrant. So then this will be my reference angle. So this is 11 pi 6. Okay. So this is my first angle. This is my second angle. Okay. Now to do the B part, it is the same thing that we did here. So if I add to pi 6, if I go one rotation and come back, it'll give me the other angle. And if I keep rotating, it'll make same thing to 11 pi 6. So to pi 6, I add 2 pi k. And to 11 pi 6, I add 2 pi k, where k is an integer. So the first part is finding the angle where it is positive. But in this case, since the function value that was given to you was positive, the reference angle and the first angle ended up being same. And then we use that to find the other angle. Okay. Hope this. Let me know if you have any questions. The third problem is for tangents. So my first step is the same. Take the inverse of both sides. Negative square root of 3. So these cancel off. So theta is tangent inverse of negative square root of 3. So again, now to find the reference angle, I will figure out where is tangent positive square root of 3. Okay. Tangent is y over x. Okay. So if I'm looking at this, I want square root of 3 in the numerator. So if I'm looking at this, this is the case where y is square root of 3 over 2 and x is 1/2. So at pi third, what I notice is it is the x and y value is 1/2 and square root of 3 over 2. So if I do y over x, I get square root of 3 over 2 over 1 over 2. So keeping this constant, take the reciprocal, the 2 divides off. So square root of 3 over 2, keep the numerator as it is, take the reciprocal, it is 2 over 1, the 2 cancels off. Okay, so this is where it is positive. So where is it negative? It is negative in the second quadrant, and it is negative in the fourth quadrant. So this is my reference angle. So I use it. It will be in the second quadrant. So my reference is pi third. So this is 2 pi third. The first angle where it is 2 pi third. This is my reference angle, pi third. So where is it? Theta reference is pi third. And then in the fourth quadrant, it will be 5 pi third because y is negative over this. So it is 5 pi third. So this is my first step to figure out all angles where tangent is negative square root of 3. Then to find the B part, which is easy, the 2 pi third plus now. Here it is 2 pi k because the period is 2 pi k. Here the period is pi k. In the case of tangent and cotangent, it is pi, period is pi. And 5 pi third plus pi k. K is an integer. The last problem on this page is 2 sine theta plus 1 equals to 0. I need to first solve for sine. So all these were already solved for the function value. In this case, 2 sine theta is equal to negative 1. Divide both sides by 2. Sine theta is equal to negative 1/2. Take the inverse of both sides. I get theta is equal to sine inverse of negative 1/2. So I need to find my theta reference. I'm going to look at the angle where sine is positive 1/2. So it is in the here sine, which is the y value, is positive 1/2. Okay, so this is my reference, pi 6. So I take this. So where is sine negative? Sine is negative in the third quadrant, and sine is negative in the fourth quadrant. So in this case, it will be 7 pi 6. The reference angle is pi 6. And the reference angle here is pi 6. So these are the two angles where sine is negative. Now, in this case, it is much easier to figure out because on the unit circle, we already have labeled it, okay? But In the, I'm going to stop here in a few minutes. In this case, in the case when we are using the reference angle for an angle that is not in the unit circle, we need to do certain calculations. But here we know that if pi 6 is the reference angle, then the angle is 7 pi 6 because we already see it as a multiple. Okay. So let's look at this. So in this case, the first angle is going to be 7 pi 6. And the second angle is 11 pi 6. To complete the B part, it'll be 7 pi 6 plus 2 pi k because the period of sine is 2 pi. And here again, 11 pi 6 plus 2 pi k, where k is an integer. I'm going to stop now.